In this tutorial, we're gonna give our player some movement and make him run perpetually forward. So let's do that. First, let's go ahead and delete this bridge from our scene. This is so that we could develop our game quicker. We'll fix it later, but right now all we care about is the player's behavior. Next, click on the player's game object from the hierarchy and attach a character controller component to it. This is what's gonna let us push our player around the scene. Let's scroll closer. We can see that the capsule created by the character controller isn't centered properly. It needs to encompass the entire body of the player. So let's elevate it by 1 unit, and let's change the radius because this seems too wide. Let's make it, say, 0.3. Now let's go ahead and create a folder by clicking the plus sign, and we'll name it scripts. This is where we're gonna keep all of our scripts. It will make our project much more organized. Double click on the folder, and hit the plus sign once more to create a C# script. Let's name it player controller because it's going to control the behavior of our player. Now we need to attach the script to our player game object by selecting the player's game object from the hierarchy and dragging the script onto it, like so. And before we open the script in Visual Studio, let's make sure that Visual Studio is integrated into our Unity development environment. Select Unity from the menu bar and go to Preferences. If you are on Windows, go to Edit and then Preferences. Go to External Tool and make sure that Visual Studio is selected from the External Tool Editor. Also, hit Regenerate Project Files to be sure that Visual Studio is properly integrated with Unity. Now close this window and open up the Player Controller script. This is the default layout of every Unity script, and it's written in C#. Now I could sit here and tell you what each line does with excruciating details, but honestly it won't be of much help to you. We'll instead learn bit by bit how to use scripts in Unity, and then you'll have a much better idea of how scripts work in Unity. The first bit is that all of our code needs to be contained within these curly brackets, else it won't work. So if I go outside the curly brackets and type int a equals 5, semicolon, it will show an error even though the expression is valid. So our code must be within the brackets. The second thing you need to make sure of is that the name of your script in this line matches the name you've given it in the Unity editor, letter for letter, case sensitive. Otherwise your script won't work. And don't forget to update your Visual Studio to the latest release. If you're on Windows, just go to Visual Studio Installer from the Start menu and update your Visual Studio accordingly. It looks like I have to update mine. We'll resume this tutorial after it finishes. Okay. So let's explain why we need scripts in game development and in Unity specifically. The character control component that we have attached to the player game object can't do anything on its own. We need to tell it how to move in the scene and under what conditions, otherwise it just sits there doing nothing. So let's make it do something, i.e. move the player forward. The first thing we need to do is to activate the character controller component that is attached to this player from inside the script. To do that, we need to create a variable of type character controller. A variable is just something that stores a value for it to be accessed and modified later in the code, hence the name variable, because it can vary. Type in the variable type first, followed by the variable name before the start function. And as you can see, if I type ch, Visual Studio auto-completes the rest for me, which is very nice. This means that it's properly integrated with Unity. We'll name our variable small c character controller and follow it by a semicolon to end the line. So nothing should come after the semicolon in this line. Now you could name your variable anything you'd like, just make sure that you name it something logical, so you know what it does. Also, when naming two words variables in C#, we use the convention of making the first word all small letters and capitalizing the first letter of the second word. It's just a convention that we'll be following. Now we've declared the variable and haven't done anything with it. We need to link it with the character controller component that's attached to this player game object. To do that, let's step into the body of the start function, and we know that this is a function because of the parentheses and the curly brackets that come after the name. And if you're wondering what's a function is just a block of code that's organized under a specific name. In this case, it's start, and this start function is a predefined function in Unity. In the next tutorial, we're gonna write our own functions, and then perhaps you'll have a better understanding and appreciation for functions. Let's step into its body and type character controller, small c, and set it equal to this dot gig component bracket character controller parentheses. Terminate the line with a semicolon. This line simply means in C#, get me the character controller component that's attached to this game object and assign it to the character controller variable left of the equal sign. And the reason we do this is because there could be other character controllers attached to different game objects in the scene. There could be other players in the game, if you think of a multiplayer setting, for example, each one with their own character controller component. And one last thing about the start function. Unity executes the code in this function first, hence it's named start. And it's precisely the reason why we always use this function to initialize variable, meaning setting them equal to an initial value, just like what we did with the character controller. I apologize if I'm over-explaining things, but I really want to make sure that you understand how scripts work in Unity. Okay, now let's declare ourselves a float, which we will call player speed, and set it equal to 10 units per second. And you can see that we're still following the same naming convention here as well. A float is just a variable type that stores a decimal point, like 12.5 for example. Let's also create a vector 3 that determines the player's direction in the game, which we will call player vector. A vector 3 is just a variable that stores 3 values, conveniently named x, y, and z. Let's write a comment by inserting 2 forward slashes after the semicolon. Unity actually skips the green part of the line and it doesn't run it, so this is just for us to denote things that are worthy of remembering. Now we've just declared it, but we'll initialize it in the start function, just like the character controller variable. Let's add a new line and type player vector equal, and now I'm gonna assign a direction to it. So let's type new vector 3, and you can see that Visual Studio is helping me along the way, which is very nice. Do we want our player to move in the x horizontal direction? Not yet, so put a 0. Do we want our player to move in the vertical y-axis? Not yet also, so put a 0. Do we want our player to move in the forward depth direction, which is the z direction? Yes, so let's put a 1. Now we have specified a direction, but we need to tell the player how fast he should move in that direction. So let's multiply this expression by player speed and terminate the line with a semicolon. And now the player speed gets multiplied to each individual term of the vector 3. It gets multiplied by the x component, which is a 0, so it stays 0. Then it gets multiplied by the y component, which is also a 0, so it remains 0. And then it gets multiplied by the z component, which is a 1, so it becomes 10, which is the value that we have specified for the player speed. So this is actually the same as vector 3, 0, 0, player speed. Are we done yet with this line? No, because this is 10 units per frame. We want 10 units per second. To do that, we need to further multiply it by time dot delta time. This is the per second converter in Unity. Now if I change this 1 to a -1, then my player will move in the backward direction with a speed of 10 units per second. If I change this to a 1, then my player will ascend in the vertical direction 10 units per second. And if I change this to a -1, then my player will descend in the vertical direction 10 units per second. Also, if we change the x component to 1, then the player will be moving in the east direction 10 units per second. If we change it to a -1, then the player will be moving west 10 units per second, and so on. I hope that you get the idea. So now we have our direction, we have our speed, and we have our character controller component. We need to combine them all together somehow to make our player start moving at last. And we do this in the update function, which is also a predefined function in Unity. It differs from the start function in that the code that gets written in its body keeps getting run in a loop once per frame after you hit the play button. So if our game is running at 30 frames per second, this function gets called 30 frames a second. Now let's step into the body of the update function and tell our player to start moving in the forward direction with a speed of 10 units per second. But we still don't know how to do that. Therefore, we need the help of the Unity manual, which is the best resource for learning how to use different functions in Unity. We will be using it extensively throughout the course, so familiarize yourself with it and learn how to use it. We want to use the character controller to push our player around the scene. So let's look for character controller in the manual and see how we can use it. So open up a browser and search for Unity manual character controller. Go to this result or go to this link directly. This page has useful information on how the character controller component works. Let's quickly read the description. The character controller is mainly used for third-person or first-person player control that does not make use of rigid body physics, meaning it allows us to move our character without having to worry about the physics of the game, like weight or wind. But we actually need to scroll further down and go to this page. And we're really interested in the methods section. Each component in Unity has its own set of methods that extend its functionality. And so the Unity manual tells us that the character controller component has 2 methods. move, and simple move. And the description of the move method reads, supplies the movement of a game object with an attached character controller component. It sounds like what we want, so let's click on it to learn how to use it. It says here that the move method takes in a vector3 as an input argument. So this move method says, you supply me with a vector3 and I'll move the player accordingly. Think of methods as vending machines. They have an input or an argument and then they produce an output based on that input. The input may be a dollar bill and the output might be a soft drink. That's a useful analogy that I use for myself all the time when I think about methods and functions. And below it even has an example script to show you how to use the character controller. So let's go back to the player controller script and type c character controller dot to access all the methods of the character controller component, and then type move parentheses player vector and the line with a semicolon. So this line here basically says invoke the move method on the character controller component on the player vector variable. And now when we hit play, Unity is gonna execute the script line by line. So first it's gonna declare all the variables here, then it's gonna initialize them in the start function, and then it's gonna run this line in a loop over and over until we stop the game or tell it to stop. Now let's go back to the Unity editor and play our game to see if everything we did checks out and works as intended. We can see here that we have the scene window tab and the game window tab. Let's drag the game tab window to the side so that we could have a more efficient split view. If somehow you didn't have a game tab window, then go to window from the menu bar, then go to general, game. Now I want to look at my player from the side so that I could see him move. We know that our player is facing forward. So let's pick the hand tool and right click and rotate like so. Okay, this would give us a good view of our player to test our scripted behavior. We can see that we have one view in the scene window and another view in the game window. To make the view of the game match the current view of the scene that you see right now, click on the camera game object, and then from game object, select align with view. Now the views match, and if I hit play, we can see that our player is moving in the forward direction. If you want your view to be exactly like mine, then copy the transform values of my camera into yours. And don't worry, we'll fix it in a future tutorial to make it more like the actual game. Make sure that you save the changes by hitting Ctrl S or Command S if using a Mac. Okay, this marks the end of this tutorial. I hope that you've learned a lot from it. I tried to explain things as intuitively with good amount of details as I can. We'll continue our work on the player logic in the next tutorial and implement a gravity effect to make him fall off the bridge. Thank you.